domain.
Okay.
Yes.
Then all trigonometric functions are continuous functions.
Yes.
The functions, continuous functions. 4. Modulus function. Modulus function is continuous.
Yes. In its domain.
Yes. So what is modulus function actually? F of x equal to
F
f of x equal to mod x.
Yeah, mod x, so it should be minus x if x is less than 0, or an x if it's greater than or equal to 0.
So that means very clearly, if at all you have to have discontinuity, that is at 0. But at 0,
Yes.
so left hand limit is 0, right hand limit is 0, function value also 0. And
Yes.
you can say this is a continuous graph like this. So this continuous, there is no gap.
Yes.
Next, 5. Greatest integer function.
It's the function where if there is a number, it's going to it's the function is going to be the integer that is lesser than or equal to it.
Yeah.
So suppose it's 2.1, it would be 2.
Correct. This is n if x lies between n and n plus 1.
Yes.
Where n is an integer. If it's between n and n plus 1, like you have that integral part of 2.2 is what is 2, because 2.2 lies between 2 and 3.
Yes.
So it lies between 2.2, lies between 2 and 3, therefore we take 2.
Yes.
If at all n lies x lies between n and n plus 1.
Yes.
Then we take n.
Yes.
Sometimes it is minus 5.2. Okay, minus 6, this one. Why?
Yes.
It lies between minus 6 and minus 5. So you have to take left number.
Yes.
So is this continuous function?
Is it continuous?
It's 0, 0.
Yeah.
0.
If we take 0, then it won't be continuous. LHL will not be RH. Equal to RH.
At 1, its value is not 0. At 1, it is 1. 0.999 also 0 only. Here only I wrote.
Yeah, right.
It is 1. 1.1, 1.1, 1.2, 1.5 is 1 only, like this only.
Yeah, you're right.
Also 1 only. But when it comes to 2, it is not here. It is here.
Yeah. Yes.
Like this graph will be like this step.
Yeah.
Step function we say this one.
Yes.
Like this it is. So it is, so greatest integer function, GI, greatest integer function, is discontinuous. It's not continuous function, it's discontinuous at all integers.
All integers.
At 1 discontinuous, 2 discontinuous, minus 1 discontinuous, minus continuous, like 0 it is discontinuous.
Yes.
Why? How do you check? Limit x tends to 1.
Yeah.
X is how much?
It's 1. Oh, no. X tends to 1, there'll be 0.
Good, because it's 1.9999. 1 minus.
Yeah.
We have to find out limit x tends to 1 f of x, modulus x. But we LHL, RHL.
Yeah.
RHL is limit x tends to 1 plus
1.
This is 1.
Yes.
So actually limit doesn't exist. So
Yes.
limit is not equal to right hand limit.
Yeah.
Therefore, discontinuous at 1.
Yes.
Similarly, you can prove it is discontinuous at all integral points. Same, all integral. At 2 also it becomes left hand limit is 1, right hand limit will be 2.
Yes.
So therefore, generally what we say is let n belongs to n natural, or for that matter we can say it's integer. N is an integer. Let n belongs to z integer. And left hand limit at integer, this n, limit extends to n minus integral part of x is how much, tell me?
It'll be x minus 1.
There is no x. You have to tell in terms of n. Like this, you told no 1.
N minus 1.
Ah, good, n minus 1. Limit extends to n plus 1. Integral part of x. This is
N.
good. Like this, you have to see. Now you can take any integer. So left hand limit is not equal to right hand limit, therefore it is discontinuous at all integral parts.
Yeah.
So you need to remember this one.
Yes.
Next, signum function. What is that? Signum function is, okay, f of x equal to, you know what, signum function. Minus x is less than 0. X equal to 0, it is 0. Is greater than 0, it is 1.
1.
This is what is signum function, or you can say simply it is x, you can say, or mod x by x. If x is not equal to 0. From this only you get minus 1 or plus 1.
Yeah.
And it is 0 when x equal to 0.
Yeah.
This function is definitely discontinuous. Yes or no?
Yes.
Why? Where it is discontinuous?
It is continuous at 0.
Yeah. Graph will be like this. 0, it is 0. It is
Yes.
less than 1, it is 1 over here. Less than 1, it is minus 1, like this. So minus infinity to 0, it will be, and here you have to lift and come here, and then lift and come here.
Yeah.
So left hand limit will be minus 1, right hand limit will be 1, and function value is 0.
Yeah.
At 0. Therefore, it is discontinuous only at 0. Okay, these are the standard functions which you need to know. So, if you don't have any doubt here, 18th question, till 18th question.
Yeah.
19. 19, are you clear?
Yeah. X minus. So can you show it?
Meaning, shall I do and show?
Yeah. Yes.
Yeah, here this x is there, minus integral part. From x to remove, if you subtract integral part, you will get what?
So, sorry, I couldn't hear you.
Fractional part. So x minus integral part will give you fraction part. Okay. What is that? So 5.2 minus integral part of 5.2.
Yeah.
Integral part is 5.
Yeah.
5, then you get fractional part or decimal part.
Yeah.
So that's also discontinuous at the same integer point. So you can write LHL is same. LHL equal to limit extends to 1 only, you take 1 minus x minus integral part of x. Let's say this is the function. Then this becomes 1 minus 0, na? 1.
Yes.
Limit extends to 1 plus x minus integral part of x. How much is this? Sorry, integral part of it. How much is this?
It will be
1 minus 1.
1 minus 1.
Same thing only. X is same. Integral part here is 0. Integral part is 1 place, no more than. Therefore, it becomes 1.
Yeah.
Equal to right hand limit. Therefore, it is discontinuous at 1. But what we have to discuss is n minus n.
Yeah.
You write n minus 1. This is n minus n minus 1. It's always 1. Here this becomes minus n. This is 0 always.
Yeah.
So therefore, it is discontinuous at all integral points. Here denotes the greatest. Okay.
Yeah.
What about 20?
20. Is
the function defined by f of x equal to x square minus sin x plus 5, continuous at x equal to pi or not.
Isn't this a polynomial?
Yeah, this is polynomial. X square plus 5 is polynomial, and this is 3.
Okay. Would be continuous.
Good, continuous at all points. So continuous function. So therefore, here we see algebra.
Right.
Of continuous functions. Algebra of continuous functions. What is that algebra of continuous? Yesterday, okay, we don't know. Okay. Let f comma g are continuous functions. I'm writing.
Yes.
Continuous functions are even continuous at one point. Then what? Number 1, f g is also continuous.
Okay.
And f minus g is also continuous. Where it is continuous? Functions, na?
The domain of the function.
So let's say df is domain of f, and g is domain of g is dg is domain. So they are common domain, intersection. Domain is continuous. So same results, common domain is continuous. F into g is also continuous, common domain, and f by g also continuous in its common domain.
Yes.
So here what is given? X square minus sin x plus 5. So what you should do here is you have to tell that x square plus 5 is what is polynomial. Continuous. Polynomial continuous. Sin x is trigonometry continuous. Continuous minus continuous is continuous function.
Yes.
So here this is real number. This is all real number. There is no. It's continuous for all real numbers. It's continuous function means it's continuous on its domain, which is real numbers.
Yeah.
Like that you have to show.
Okay.
So similarly, now what can you say about this? 21.
Sin x plus cos x will be continuous because both of them are continuous.
Okay.
The same thing goes for this. This will also be continuous. This should also be continuous.
Yes. So discuss continuity of cosine, cosecant, secant, and cotangent functions. Continuity of these functions.
Cosine
is continuous function.
Cos.
Cosecant is cosecant. Cosec function is continuous. All continuous only. But discuss the continuity. How do you discuss continuity?
So where they are so we need to find the domain of each of these.
Yes.
We need to specify the domain of each of these.
Yes.
Cosecant. It wouldn't be.
First of all, we will not give you this question in exam. Because see, for example, cos. Let's say f of x equal to cos function. Cos it's discuss its continuity. So here, let x equal to a we take. Understand? Some a.
Yeah.
where this belongs to all real numbers. Any real number. A is any real number.
Yeah. Yes. X is any.
Okay, we'll write like this. At x equal to A will discuss, which is real number will discuss. Okay. Now simply write like this: limit x tends to A cos x equal to what? Left hand limit or right hand limit? Cos A only.
Cos. Yeah.
Cos A only. Because I told you, if you have denominator and if it goes into indeterminate form, then you have to use some method, but it is only, only.
Right.
No question of any problem. But whereas if you take cosecant, f of x equal to, you have taken cosecant, means what? Then there is a problem where
shouldn't be 0.
0. So therefore it is
should be 0. Yeah.
Yes, continuous at all their numbers, but not for n pi. N pi.
Yeah, n pi.
N pi. N pi means what? 0 pi means 0. 1 pi, 2 pi.
Yeah. Pi. Yeah, all multiples.
Multiples of pi, yes.
Yeah.
So similarly, secant is odd multiples of pi by 2. 4 tan.
Yeah.
That is cot. Cot is like secant only because cos by sin are same.
Yeah.
So, but anyway, it's continuous functions only. Cosecant is continuous, secant is continuous, but its domain, they are continuously continuous. So you should know the domain. So 23, find all the points of discontinuity of F. Is there any points of discontinuity for this?
We should check at 0, right?
Yeah, we should definitely check at 0.
Sine 0 by 0, that's an indeterminate form.
But do you know this one? Limit x tends to 0, sin x by x is how much? Limit, if you don't know, you should write this.
Sin x by x is 1.
Good, 1. This is also 1. Limit x to 0, cos x is 1.
Okay. Yeah.
Sin x by x is 1. Here tan x by x means what? Sin x by x by cos x. Because sin x by x is 1, 1 by 1. That is the reason it's 1. Cos x is substitution. Nothing is there in the term. Limit x to 0, cos x is cos 0 is 1.
Yeah.
Only one thing. This is anyway direct substitution. When this comes in the first year, we have a theorem. Proof is also, you can go back and x by x is 1. But anyway, they will not ask you the proof. You should know only.
Yeah.
This formula you should remember. So limit at 0 is what? X tends to 0 minus, na?
Yes, 0 minus.
0 minus, left hand limit.
Yeah.
So that is x is tending to 0 from left hand side, means sin x by x you should take, and we have taken sin x by x, which is 1.
1, yeah.
And limit is limit x tends to 0 plus. F of x is how much? More than 0.
So
X plus
1.
1.
Yeah.
And x equal to 0 also same. F of 0. When you put x equal to 0, 0 plus 1.
Yeah, right. 1.
So 1.
So it's
1. So it is find all points of discontinuity of F. Discontinuous point exists only at x equal to 0. It will exist x equal to 0. We have checked.
Yeah. Yeah.
Equal to 0, it is continuous.
Yes.
Okay, determine if F is defined by this is continuous function or not. Continuous function means it is yes at all the points.
We'll have to check 0 again. No, wait. No. It'll be continuous because both sides will have the same. LHL and RHL will be the same. But, yeah, no, it won't be continuous. Because F of 0 would be.
We have to check only at 0.
Sorry?
We have to check only at
We only have to check it x equals 0.
Yeah.
So LHL would be what? How 1 by 0? No, not 1 by 0. Okay.
You should know sandwich. Do you know sandwich theorem?
Sorry, sir?
Sandwich theorem.
No, sir.
What is that, you know? Let F
No, sir. Yeah.
G is less than H.
Yes.
Okay. Let this one. If at all, limit x tends to a f of x equal to x tends to a h of x. Okay.
Yes.
Then what happens is limit x tends to a g of x is also L. This function is tending to L. This function is to L. Between this g is there between this, then that function domain also becomes L.
Okay.
This you have to do like that. How you have to do? You have to 0. So limit x is to 0. 0 minus 0 plus both are this. X to sine 1 by x. Okay?
Yeah.
What we need to find. But we want to find here 1 by x, understand x is not equal to 0. X approaching 0. X is approaching 0. X not equal to 0. 1 by x not defined. Sine 1 sine 1 is not no meaning. So here sine 1 by x is sine 1 by x is not 0, but it like it is minus.
Yeah. Yes.
So now what I want x square, I want so multiply x square. X square on both sides. Then minus x square is less than or equal to x square into sine 1 by x.
Yeah.
X square.
Yeah.
Now what you should do? You have to find out limit, apply limit. Limit x tends to 0 minus x square is less than or equal to limit x tends to 0 x 1 by x, which is less than or equal to limit x tends to 0 x square.
Yeah.
So what do you get this one? First one?
0.
0. Last one?
Also 0.
0. Limit x tends to 0. X square, no, only x square. Problem in direct substitution 0. So in between 0 less than or equal, this less than or equal. This lies between 0 and 0.
Yeah.
0 and 0 impossible. This must be 0, right?
Yeah.
So like this you have to do. This is 0. And 0, which is equal to f of 0.
Yes. Correct. Yeah. So it's continuous.
So therefore, here limit x tends to 0, f of x is 0, which is equal to f of 0.
Yes.
Okay, other points you need not check.
Yeah.
You have to note this sandwich theorem.
Yeah.
Differentiability. Are you able to do differentiability?
Yeah, I know how to do differentiability.
Sure.
I know how to differentiate.
You don't know?
I know how.
Differentiability is differentiation, and differentiability means you should know. Okay, the differentiability once we will see. Differentiability. Differentiation.
Okay. Isn't that when the left-hand derivative should be equal to the right-hand derivative?
Yes, exactly.
Yeah, that one. Yeah, I remember doing that.
Yes, okay, good. So no problem. Then what we'll do is we'll do this exercise. And if then what we can do is we can do some important questions from this exercise, and then we can.
Yeah.
When you have half yearly, you have anything like that, half yearly or midterm exams?
Oh, yes, sir. We have half yearlies. We got our portion sheet today.
Very good. All the chapters are there, I think.
No, we don't have every chapter. Should I read out the portion sheet?
Yes, Hans.
Okay. Relations and functions, inverse trigonometric functions, matrices, determinants, continuity and differentiability, applications of derivatives, integrals, applications of integrals, differential equations, and linear programming.
Oh my God. Everything is there. What all happened? Everything is there.
It's all there. I thought there were a few chapters that are still not there.
Oh, everything, what all happened, everything is there. Can't what? Integration is not fully, but integration is there.
Yeah, no, they haven't
Yes.
finished integrals in our
Yes.
class. We haven't done anything from we haven't done applications of integrals, differential equations, and linear programming in our class yet.
Yeah, yes. Exactly. Yes.
There's a lot.
Yeah. So whole syllabus is there almost. Okay. So that means continuity differentiability is there.
Yes.
So we'll discuss few problems from continuity, which are important.
Yeah.
Combination point of view important we'll discuss. That's okay. So anyway, this is the 25th is direct and obvious. When x, you have to check it x equal to 0. You have to
Yeah.
equal to 0. But here, if you see, here this is limit extends to 0. 0 minus is this, 0 plus is x is not equal to 0, meaning what? X is less.
Yeah. Yes.
So limit extends 0, sin x minus cos x.
Sin x minus cos
Minus
x.
direct substitution 0.
Yeah.
Sin 0, 0, cos 0 minus, like that. And when this is nothing but what f of 0.
Yes.
So direct, so continuous. So you have to find k. Do you remember this? How do you find k?
If they said it's f is continuous at that point, we have to compare LHL and RHL.
Yeah. So now what happens is limit extends to pi by 2 na? Into x, that is k cos x.
Yeah.
X pi minus 2x.
Yes.
This is equal to, he gave
Yeah.
f of pi by 3, है ना? Limit extends to pi by 2, f of x is f of pi by 2. Pi by 2. Right? Limit extends to a f of x is f of a. Like that. Pi by 2, pi by 2?
It's 3.
Okay, 3. And k cos x by pi minus 2x.
The denominator would become 0 in that case.
Exactly. So 0 by 0 only.
Sorry?
0 by 0 form you are getting.
Yeah. Indeterminate form, yes.
So therefore, pi minus 2x you assume as some y.
Okay. Y.
2x equal to pi minus y.
Yes.
X equal to pi by 2 minus y by 2.
Yes.
Yeah, x minus pi by 2. See, x minus pi by 2 equal to minus y by 2.
Yes. So why did we subtract pi by 2 from x?
Okay, I'll tell you. Just we need to replace x, that's it. We need to replace x.
Okay.
Okay, assume this is you have to assuming help us. So here anyway, limit here x is what? Pi by 2 minus y by 2, no?
Yeah.
Minus y by 2, no?
Yeah.
So x tends to, so here x is here pi by 2 minus y by 2. This tends to pi by 2. like that. Now
Yeah.
k into cos x, what? Cos of x means pi by 2 minus y by 2.
Yeah.
By this is simply y.
Oh.
This
Oh.
it is like this. If you substitute, then it will be easy actually.
Yeah. Okay. Mm, isn't cos of pi by 2 minus something equal to sine of
Yeah, so
sine y by 2?
you can cancel off, pi by 2, you can cancel off. Now what you have? Limit minus y by 2 tends to 0.
Yeah.
And here what you have? K cos pi by 2 minus theta. Cos pi by 2 minus theta.
Is sine theta.
Very good. Here y by 2. So sine theta. Sine y by 2. By.
So why did we cancel off pi by 2 and pi by 2?
Pi by 2 we can cancel off. Anyway, if you take that side, it will be same only. No?
Okay. Yeah.
So here y.
Yeah.
3. Now here k you can keep aside, and here sine y by 2 came here. Here also
Yeah.
y by 2.
Yeah.
Then what you can sine x by x is 1, no? Like that.
Yeah. 1.
Yeah, limit this minus you can remove, y by 2 tends to 0.
Yeah.
Sine of y by 2 by y by 2. Everything
Yeah.
okay. Now you know this whole thing is
Yeah.
how much is this limit y tends to y by 2 tends to 0, sine y by 2 by y. Sine means what? Y by
1.
yes, this one. So k here k into 1 by 2 is what?
2.
K equal to 6. So you have to remember this.
Okay.
Textbook, this is only very important problem.
Yeah.
Remaining, you know, this one, you know.
Yeah. Kx. Yeah.
Kx square, that is direct, no?
Yeah. Yeah. Yeah.
Next, what else?
Mm,
27, kx square means what? K into
yeah. Yeah. Yes.
28 also same. Pi.
Yeah.
What is cos?
Yeah. Sorry, I couldn't hear you.
Cos pi. 28
Cos pi is minus 1.
Yeah. Like this, not pi minus is equal to limit extends to pi plus. I am writing cos x.
Yeah.
So this is pi k plus 1 equal to cos pi x is minus 1. Like that you get.
Yeah.
2 minus 2 by pi. Like this. Simple.
Yeah.
29 also direct. 30 can you do once?
30th.
30th. Try. Just 1 minute only. Just 1 minute you can finish off.
Should we check at 2 and 10?
Yeah, exactly. See, find the values of a and b such that the function is continuous function. If it is continuous function, what should be a and b values? It depends on a and b values only,
Okay, so they're a continuous function. Okay, so means it's continuous at all points, right? 2 plus ax plus b. So we get that ax plus b is equal to 5. And we also get that a.
So if you apply limit at 2, left hand, right hand limit, what you get is 5 a plus b equal to 5. What you said 1.
Yeah.
And at right hand,
Yeah.
10 if you take left hand limit is 10a plus b. But the right hand limit is this one.
Yeah. Yes. Yes. And then we just we use elimination and we find answer. Should be minus
Yeah.
minus 16. Minus 16 equals minus 16a is equal to minus, yeah.
Right.
A is equal to 16 by.
Anyway, so remaining things we'll discuss later. Okay.
Yes.
Yeah, we'll discuss later. Somewhat today I'm not well, so that is the reason I have to late and close soon.
Okay.
Okay, so this much you learn, and some important I told you, for exam important questions are that I will cover along with you. Want to?
Yeah.
Okay,
Okay.
thank you, thank you.
I thought this 31 to 34 is deleted according to my teacher.
Oh, really? I'll see one.
Yeah, apparently the proving questions are
Yeah,
deleted. I'm not sure.
Possible. So I'll see and let you know.
Yes.
Okay, next class we'll see.